Energy and power are fundamental concepts in the world of physics and engineering, but they are often confused. To understand them, let's imagine a water reservoir. Energy would be the total amount of water stored in the reservoir, while power would be the flow rate at which this water moves through a pipe. In technical terms, energy is the capacity to perform work, measured in joules, whereas power is the rate at which this energy is transferred or used, measured in watts. The mathematical relationship between these concepts is as follows: power equals energy divided by time. For example, an electric motor that consumes 500 watts of energy over 1 hour will have used $500 UH of energy. The total energy consumed indicates the amount used overall, while power indicates how quickly that energy was used. This distinction is crucial for understanding issues related to energy production and usage, particularly in the industrial sector. Currently, one of the biggest challenges is that electricity cannot be directly stored in its pure form. This means that the amount of energy generated must match, in real time, the amount consumed, requiring electrical grids to constantly balance production and demand. In the industrial sector, this challenge is magnified by the high energy demand needed to power processes and machinery. Impact on the stability of electrical grids. The lack of effective storage means that when there is excess production, some energy is wasted. This is especially true in industrial facilities relying solely on renewable energy sources, such as solar or wind power, where production depends on weather conditions and may not align with demand peaks. Conversely, when demand exceeds production, outages or interruptions occur, impacting productivity and potentially damaging sensitive equipment. Overloads and losses. In industrial facilities, excess production can lead to overloads in electrical equipment and transmission lines. These overloads not only damage infrastructure, but also force certain parts of the grid offline, disrupting critical operations. Costs and efficiency. Without energy storage, businesses must invest in additional production plants or pay higher rates for electricity during peak hours. This increases operating costs and reduces competitiveness. Moreover, over-generated and unused energy is wasted, representing both an economic and environmental loss. Technological solutions and opportunities. To address these challenges, advanced energy storage solutions are being developed that allow excess energy generated during periods of low demand to be captured and released during consumption peaks. In the industrial sector, these technologies are essential for ensuring efficient and sustainable operations. Among the most promising solutions are advanced industrial batteries. Lithium-ion batteries are used to store energy and release it when needed. These solutions are ideal for factories that combine renewable energy sources with variable energy needs. Green hydrogen. Excess energy can be used to produce hydrogen through electrolysis. This hydrogen can be stored and later used as fuel or converted back into electricity using fuel cells. Mechanical storage. Technologies such as flywheels and compressed air systems provide storage solutions to balance production and consumption, especially in energy-intensive industrial processes. Thermal storage. In some industries, heat generated as a byproduct can be stored in phase change materials or molten salts and reused in downstream processes, improving overall energy efficiency. Examples from the industrial sector: manufacturing industry. In an automotive factory, the instantaneous power required for assembly robots is high but not constant. Without storage, the plant relies on the electrical grid in real time, increasing costs and risks of outages. With storage systems, energy can be stored during low-demand periods and used during peak hours. Chemical industry. High energy-intensive processes, such as distillation or electrolysis, require a constant and stable energy supply. Without proper storage systems, any grid fluctuation can affect the final product's quality and increase downtime. Steel manufacturing. Steel plants require large amounts of energy to operate electric furnaces. Without storage, they must oversize their production capacity or pay high rates for peak demand. Storage technologies help reduce these costs and stabilize operations. Conclusion. The difference between energy and power is crucial for understanding today's energy challenges. In the industrial sector, where efficiency and sustainability are priorities, the inability to effectively store energy represents a significant problem. Technological innovations in storage enable companies to optimize their operations, reduce costs, and contribute to a more resilient and sustainable energy system. Research in this field has the potential not only to transform the industrial landscape, but also to accelerate the transition to a cleaner and more efficient energy future.